Right then, so welcome to the fifth lecture on probability and statistics. So, as I mentioned last time, today we will move into a new module. Do you remember what we did last time? हुआ कब था? क्या किया?
क्लास में से नहीं बैठी देर
क्या?
क्लास नहीं है
अच्छा, कोई नहीं आया?
कंटिन्यूअस प्रोबेबिलिटी
Yes, continuous variables probability, right? If you miss a class, please watch the video. कल होगी थी ना upload. So because this is a continuity, I don't know how you will understand today's topic if you haven't even listened to the lecture. It's very hard. Okay. So please help yourself and don't make it too hard. But anyway, I have to continue. We have been talking about distributions of random variables, right? How to define that. So, as I said at the start of the course, we have 5 modules in this course, right? The first module being how to talk about uncertainties mathematically, how to assign them. Yeah. So that was the first module, assigning probabilities. The second module was about collecting those probabilities, and there we saw, so in the first module we saw, okay, how do we define, say, the probability of a random event, yeah? In the second module, we said, okay, now we want to make it more mathematical, and instead of an event, we defined a random variable, right? And we said, okay, how do we efficiently represent the collection of the probabilities of random variables? And for that, we saw that there were 2 cases at least. There was the discrete random variable and the continuous random variable. Yeah? And then we saw, okay, for the discrete case, we saw that we could assign, say we could define a function that we call what? Probability mass function, right? F of say x, which was saying probability x equals small x, right? So we collected that here, and what did we call it? Probability mass function. Now from the mass function and related to it, we had 4 others, right? There was the cumulative, yes, which gives you the probability. So what was the cumulative f of x? It was probability x is less or equal to x in a range, yeah? And we saw from here we can do all sorts of range, 2-sided bounds, 1-sided bound, upper bound, or we could try many different things. Then we did the conditional distribution, marginal distribution, joint distribution, right? All of that here. Then we repeated that here for the continuous random variable, and we said, okay, although we will still use a function like the probability mass function, we will know that it does not mathematically represent the probability of the random variable x taking a particular value, because for continuous random variables there are uncountably infinite number of possibilities, so each possibility has 0 probability by itself. So we call this instead a probability density function, and we interpreted it as saying it only tells us the relative likelihood of something happening, not really the exact probability. But with that definition, we were able to use it exactly as we use the probability mass function. If you find that a bit hard to absorb, just view the previous lectures again. I discussed it in detail. The summary is basically that for discrete case we have probability mass function, which represents this. For the continuous case we have probability density function. After that, the remaining functions were the same, yeah, except for one key difference. What was that? Other than this one, yeah? That is, summations were replaced by integrals. Yeah? So for example, you knew that, let's say if I want it to be xi here, xi, then we had said, okay, it will be defined like this. It is summation of all the fxi, yes, or let's say xj, where xj are less or equal to xi. Draw the summation of all the possible values up to that point. Yeah. Here we saw, okay, in case of a continuous random variable, the cumulative density function, which still represents the probability x is less or equal to x, was an integral, yes, minus infinity up to x and f mu b. You have to change the variable because x is showing here. So the two are very similar, it's just the same. Conceptually they are the same. But since one represents continuous distribution or density, the other represents discrete case, one requires summations, other requires continuous summation, which is integral. Yeah. Other than that, conceptually it was the same. So this was the first module, assigning probabilities, talking about uncertainties. Second was collecting probabilities in different functions. Yes, and then we had the probability density function, etc. The third module is now the one that we will cover, is going to talk about extracting key information from the density and distribution functions. What does that mean now? So from here on, random variable x will have a distribution or density function associated with it. Yeah. So yes. For example, if the random variable x is the number that shows when you roll a die, yes, is that a discrete case or a continuous case? Discrete case, very easy. Yes, I am just repeating this for a quick revision. So it represents the discrete case. Okay. So for that case, what are the possible values of small x? 1, 2, 3, 4, 5, 6. Yeah. So you will say, okay, the random variable x, that is the number showing on the roll of a die, has a density or mass function associated with it, and we can draw it like this. These are the values of x. What are the possible values? 1, 2, 3, 4, 5, 6. Yes. And what are the values? And here you will show the value of the probability mass function. What was it? It's 1 by 6. Yes. Probability of a 1 showing 1 by 6. Now look at how the mass function for this case looks like. They are all equally likely. It's a uniform distribution, isn't it? They all have the same probability. But what you need to notice is that this is discrete. What happens if I want to calculate this function at f2.5? You can still do that. In a discrete case, there is this assumption that other than these values, everything else is 0 probability. Yes? So even for the discrete case, you can put x, give it any value you like. Okay? If that value does not fall on one of your discrete cases, it's automatically 0. So from here on, every random variable has a density or distribution function associated with it, which collects the information about its probabilities. Yeah? Yahan samajh aa raha tha na? What are the possible values? 6. Are they equally likely? Is 6 more likely to occur? Is 2 more likely to occur? You can answer them. What's the likelihood that you will get a number 3 or less? Sum all of these. What's the likelihood that you will get a number, an even number, some this, this, and this. Yeah, all those things can be answered from here, from the what distribution function PDF. From here on, we will call it PDF. वो वाला नहीं जो आप word से convert. Yeah, PDF. For discrete case, the D says distribution. For the continuous case, the D says density. Okay, that's the only difference. Otherwise, we just write it PDF. The PDF of a random variable, the distribution or the density of a random variable, like this. Now, what if there is another random variable y, which represents the heights of people? Would that be continuous or discrete? Lengths are by nature continuous, and we have some idea. I'm not saying we're going to prove that it will be like this, but most people's heights are, of course, cannot be negative. Yes, and mostly they are average height people in bigger groups, and very short people are fewer, very tall people are fewer. Yes, so it's something like this. We're not proving that it's exactly this shape. I'm just giving you an idea. Now, for the heights of people, this is the PDF for rolling a die. Yes, this is the PDF for heights of people. Yeah, again, it can give us all the information that this guy was giving us, except for one information. It cannot tell you what's the chances, what's the probability that the height of a person is exactly, let's say, 176 centimeters. 176.0. It cannot tell you because that will be 0 for continuous. What it can tell you is everything else. What's the average height? What's the range? What's the standard deviation? We will see that today. But it can also tell you, okay, what's the probability that somebody is shorter than, let's say, this is 179 centimeters. What's the probability that somebody is shorter than 179? Just like you sum here, you can do the continuous sum. What's the continuous sum? Integral. Yes. So you take that, and you know what's the probability somebody is shorter than this height. What's the probability someone's height is in a particular range? You can find that area. What's the probability somebody is taller than this door? Come chance, है ना? लेकिन there are people like taller than this. Yeah. So again, what's happening? We have summarized or collected the information about the uncertainty of a random variable in a very nice function called the PDF. Yeah, and we saw that last time other functions related to the PDF. This is just a quick summarizing and revision of that. Yeah. So let's see. Now, once we have done that, we realize that actually what the PDFs, by the way, this doesn't have to be graphs always. Yeah, graphs are nice to look at. Geometry होती है ना, आप पढ़ते हैं equations. We draw their geometry, plane, intersecting, all nice for interpretation, viewing. But when you have to do mathematical analysis, it's the equations that work for you. Yeah. So we often write these as equation. So इसकी कोई equation बता सकते हैं मुझे? इसका मैथड है. This fx. Fx equals one by 6 for x equals 1, 2, 3, 4, 5, 6. Piecewise function. You define it on 6 points. That's it. What happens to the other points? All other points that are not assigned here get automatically probability 0. You roll a die. What's the probability 1.5 shows up? 0. Won't show. Yeah. Okay. What about the second one? That would be a bit hard, but that is actually one of the most important distributions in the continuous case, the Gaussian distribution. We will see that next week, but usually we write it in some form of Ex minus mu over 2 sigma square something like that. I don't remember the exact, maybe it is a square, yeah, it is a square, yeah. This exponential, decaying exponential, that is decaying on both sides, see, exponential decay from the average, both sides, we will come back to this in detail. For now, I'm just showing you the idea, what happened. We had uncertainty about something, height of the next person. We used statistical understanding or data or some other logical reasoning, like in the case of rolling the die, to assign a function to that random variable. We call it the PDF. That function had all the information we had about this uncertain variable. अगर उसकी uncertain variable के बारे में कोई भी information नहीं है, so there's nothing we have to do to find it out, right? But even if you know the range of that variable, you have information. Yeah. So we collected that information in PDF. From here on, we will often either show you sometimes as graphs and sometimes as equations, mostly as both. And in the next week, we will actually see many examples of the different shapes that the PDF takes. Okay, but that will come later. Before that, the third module that I want to start today, which I am running late again because I like to do a lot of revision, and it is extracting key information from here. Now, what is that view? It turns out that the PDF, very nice, yes, often huge function. This is easy case, but mostly things like this, Poisson distribution, lots of functions in there. It has too much information. It has all the information about the random variable, but that's too much. In most cases, it's only a few values or few characteristics of the random variable that we are interested in. For example, let's say you go for an interview, yeah, after your graduation, yeah, and the interviewer asks you, okay, tell me about your academic performance, yes, and you say, okay, I started off with a average GPA 2.8, yeah, and then next semester I didn't perform very well, it went down, then it stayed down, then I really did well, then so you take the person through 8 semesters. By the time you're done, they will be bored, right? And they will understand that you give too much information. You don't understand that they just want a holistic picture of your performance. They don't want your story right now. Maybe they can ask for it later. Yeah. So क्या बताते हैं आप उनको? What do you tell them? CGPA. Yes. So what's the CGPA? Now, this is in a way kind of a distribution or the history of your performance. Yes. But what do? We extract one index out of it. निकाल लेते हैं ना एक index. That index, for most practical purposes, is believed to represent. आपके होता है आपके नहीं doesn't represent because I also got a 3.9 sometime. Yeah. Okay. But overall, people agree that the CGPA index represents the overall performance. What does it do? It extracts some key information from here and puts it in single parameter. Yes? So this is what really happens in a lot of data analytics, a lot of statistics. We don't really go into the full distribution. We try to see the shape of the distribution, yes. Is it normal, Gaussian, Poisson, uniform? You will see those names later, yeah? We try to see that. What's the shape like? Is it straight line? Is it curved? Is it growing and then suddenly falling? How is it? How does this look like? But other than that, often we are not interested in exactly every value. Okay? What we are often interested in is some key information that we'll extract from it. And that is the third module, extracting key information from the distributions. Yeah? किसी को पता है क्या है statistics में key information जो often use होती है? Like the CGPA for that case, so statistics में क्या होता है? Yes. Why are they so important? जो statistics का जेन में आता है सबसे पहले average, mean, variance का जेन में आता है, yes, probability के साथ. Why is that? Because they are the key information that we most often work with, and that information is in here also in the PDF. We will see how to get that from the PDF. Okay, and of course relate it to real cases where we will then try to get it directly from the data without the PDF. We'll skip the PDF. Okay, that's what a lot of data analytics does. Data science also does a lot of that exercise. So let's see. Key information. I'm going to write it here, just the names. Okay, and then we will slowly go through that key information. Let's clear this out so we have space. The key information we will extract by the way, the key information itself is a lot, but in this course we will discuss the ones that are most often used. Yeah, and since it's a first course in probability, of course, if you take higher courses later in graduation or there is advanced statistics, आप में से कौन कौन लेते हैं? CS, computer science guys, you have materials. Yeah, see you there. Right. So there you will see it in much greater detail, the other ones. Yeah. But for now, the key information that I will be talking about mostly, as you said, the mean, average, yes, it goes by many names, and variance and covariance. Now, these have cousins or other related values. For example, mean also has some cousins called mode and median. I will leave that to you as a reading exercise. बहुत simple है, what is science mean, what is a median and mean. Okay. Variance has standard deviation related to it, which is actually the square root of variance. I'm just drawing a map of what we will do. Of course, I will go through each of these. The main ones I will go through in great detail, and the cousins you can just read up on your own. You will understand. It's not a big deal. So standard deviation and range, max, mean values, they are all cousins of this guy. Covariance has a cousin, the correlation. We will see that later. But these are the three that I really want you to understand. Okay? If you get them, if you get in your mind when you hear the word covariance, if there is a logical image in your mind relating to probability and statistics, you will do very well in data analysis, and every engineer has to do data analysis, their work. Yeah, कुछ भी आप करें, you will have to study thermal properties. Even if you're a managing person, managing people, you have to deal with the data. Who's putting in more hours? Who's producing more results? Yes. So everywhere you need these things. So the key information. Let's start with the first one. By the way, these three, this group has a name, one name. They are called moments. Okay? You know what are moments? Last time I discussed किया था, एक तो time वाले moments होते हैं. You know any other moment?
Yes, sir.
From physics? Yes, moment of force. Yeah? ये वही वाला. Why is it that? We will see today. Okay? So together they are called moments, these, right? And these are not the only moments, there are more. Kurtosis, skewness, they are higher order moments, but in this course we don't go beyond this one. Right. So let's start with the first moment, and we'll see why it's a moment and what does it really represent. So mean क्या होता है? Anybody? Sorry? Average? Average क्या होता है? So if I give you 10 numbers, you sum them, divide by 10. That's the average, yeah? So that is a special case of the mean. जो आप करते हैं ना इस तरह, we will see that later. That's a special case of the mean. So, or the average, let's say. So what's the average basically? Is it like if I see a probability mean, is the mean the most likely value? The value with the highest probability? Is it? So let's see, if a distribution looks like this, a random variable has low probability of being here, low probability of being here, very high probability of being here, and extremely high here. So is it this point? Is this the mean? Yes. The point that is the most probable? No. Okay, sometimes students make that confusion. The two can coincide. For symmetric distribution, the two can be the same. But by definition and by the interpretation or the real meaning, mean is not necessarily the most probable value. Okay? In fact, the mean of a random variable may be impossible. Okay? For example, for the case of rolling a die, what's the distribution like? It's like this, yes? 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Where is the mean? In this case, so if you roll a die, it takes value 1, 2, 3, 4, 5, 6 with equal probability. So what's the average value it takes? 3.5. ये लेता है ना average value. But does it ever take 3.5? No. Right? So it means mean is something else. It's not the central or the most probable value. It's something else. So what is it then? Because the mean of this random variable is actually 3.5, and probability of this random variable taking 3.5 is 0. It's never gonna show. So what is it doing? Yeah? And if you want to say, okay, it's always the central point, like this, half somehow half, then what about this kind of thing? Where is the mean now? If the distribution looks like this, these values, low probability, very high probability, then low probability, some high probability, then very low probability. This is what it's showing here. Up say from now you should be able to interpret the PDF. What is this only showing? How likely different values are. All other values which are usually not shown mean they are 0 probability. Yeah? Okay. So then what is the mean? I'm going to write two words here or two terms, and then I'm going to explain them. But please keep in mind that if you understand those two interpretations, you will really be strong in understanding what we really mean by the first moment or the mean. It is the center of mass of the PDF. Center of mass पढ़ा आपने? Yes. So if there is a uniform beam of metal, yeah, where is the center of mass? Center में, yeah. So if you have a uniform thickness beam of metal, the center of mass is here. What is that? क्या होता है center of mass? Weight multiplied by how far each point is. Yeah? But what about this kind of beam? That is getting thicker on one side. What happens to the center of mass? It has to shift. So you also see cases of discrete center of mass where you assume that the beam is weightless and then you hang some weights here. Remember? For discrete case, you assume the beam to be massless, and then you try to find, okay, where the weights will balance. When you do this, let's say the beam is weightless, what you do, how do you find the center of mass? You see, okay, this moment arm times the moment force, yes, plus this other moment arm times the force this weight is, if this is 1 kg, this is 2 kg, so on. Okay? The counterclockwise and the clockwise should balance out. That was your center of mass, yes, in physics. Actually, it's the same here. We will see that. Let's first erase this thing. The second interpretation that I'll be talking about is the expected worth of random variable. So I like to see it as saying that the mean can be interpreted in terms of the PDF, it's the center of mass of the PDF, or it can be interpreted in terms of the random variable directly, the expected worth or the expected value. Okay, what do we mean by both of these? So let's do that. We can play a game, yeah? Let's play a game, not Candy Crush. So, what do we mean by expected worth and the center of mass? Let's say we play a game. I say that we toss a coin. Okay, if there is a head coming, I give you 100 rupees. If it shows a tail, you give me 100 rupees.
You are wrong.
Yeah, what?
You are wrong.
Right. So, if a head shows, I give you 100 rupees. If a tail shows, you give me 100 rupees. Yeah? What's the expected worth of this play?
200.
200? Is it? So, in this case, expected worth, let's define it, would mean how much do you expect to win per play on average. Let's say we play this 10 times. How much do you expect to win? How much? Sure. So say
200.
if there is a head, I give you 100 rupees. If there is tails, you give me 100 rupees. Let's play this 10 times. क्या expect करते हैं आप? कितने पैसे? क्या हो गया?
1000.
अच्छा, if we toss a coin 10 times, how many heads do you expect? 5? Yes? Expectations यही है ना? Tails 5. You give me 500, you pay, I give you 500. क्या बना? Expected value क्या है इसकी? इस गेम की per play? 0 है. गेम को कोई खास फायदा नहीं है, right? Okay. So remember, expected value doesn't mean what you will actually win. If we play only once, of course, either you will get 100 or I will get 100. Yes? It doesn't mean what will actually happen. It says what's the average worth if you repeat this thing 10 times. What do you expect this value to be? So let's draw it out and say, okay, let's clear this. I said, remember assigning probabilities, experiment, yes, all that. Sample space, head, tails. Since the head and tails are not really random variables, let's convert them to some values. In this case, we already did. We said if it's a head, you get 100. If it's a tail, I get 100. So let's call that 100 and minus 100 for you from your perspective. Yeah, when you get 100 is plus 100, and you give me 100 is minus 100 for you. So what are the possible values of this random variable x? x1 and x2. Are they equally likely? Yes. Are they is this a random variable? Yes, because it's based on a uncertain event. आपको नहीं पता toss में क्या आने वाला, right? So now the expected worth of this experiment, and of course there is an assumption here. What's the assumption? That this coin is fair. कोई trick नहीं है उसमें. Not a loaded, fair का opposite जो होता है loaded coin. Yeah. So what does that mean? What's the density function like? It says that the probability x1 value is 1 by 2. The probability of x2 value is also 1 by 2. They are both equally likely. Yes? Okay. So it's because we are assuming the coin is fair. So the expected worth of this game, expected worth Let's say as I said, we repeat this, or even if we want, you win 100 rupees. Yes. What's the probability in every play you will win 100 rupees? 1 over 2. What's the probability that you will lose 100 rupees every play? 1 over 2. So the expected worth is doing what? It balancing out the probability of something happening multiplied by the magnitude of that. We will see that soon. In a different example, you understand. Now, that's the expected worth, and logically you already know that for this game the expected worth is 0. If you play it long enough, it's 0. There will be equal number of heads and tails, and you give you the same amount of money that you get back. So expected worth is 0, and you can calculate this to see. Yeah. Now, that's the expected worth interpretation. Okay. What about the center of mass interpretation? Okay, let's see that. What if I say that I draw the random variable x here. Okay, what values are possible? x1 and x2. Yes. What is the value of x1? In this case, actually, so I want to be on the left, so we can do this x2 and this is x1, just so that we have minus 8. Okay, so this is minus 100, and this is value is 100. Now you lose 100 rupees. That's the worth, the value of what you will not lose. Lose 100 rupees or win 100 rupees. What's the chances that you will lose 100 rupees? 1 by 2. What are the chances that you win 100 rupees? Again, 1 by 2. Now apply the physics center of mass idea here. Yeah? What is the center of mass idea? Where should you place the wedge to balance out this? Yeah? Treat these as the other beaming, what you were doing. If you hang loads here, let's say 2 kg, 1 kg, 3 kg, and then this is the distance. So these weights, the probabilities are the weights, and this is the moment arm. Moment arm is how much you expect to win or lose. Now, if you look at this, of course the wedge will have to be here, so that what will happen basically is you will write it as, let's see, mu x will be x1 fx1, this is the moment arm x1, times the probability of x1 happening, meaning this how much weight it's applying here, 1 by 2, plus x2 f x2, which is what we did here, didn't we? Yeah. Okay. 1 by 2, this is 1 by 2. What's the moment arm in this case? 100. 100. What's the moment arm here? Minus 100. Minus 100. Same thing. So both interpretations come to the same conclusion, that the mean is basically, either you can say it's the expected worth of the random variable, or it's where the distributions balance out in terms of center of mass, not just the middle point. Yeah. So we will see another example now that will make it clearer. But so this has a moment arm of x1. This has a moment arm of x2. There is counterclockwise, so the moment arm is negative. Yes, and the weight is here. Now, actually, this is how we define the space here. So let's place some of these dots. now I will write the definition of the mean value, which is actually, we write it as E of x E of x, the expected value of a random variable x. If x is discrete, we define it as, in this case, summation x f x. Okay. All the possible values that x will take. Yeah, we could put xi here for the discrete case if you like. Overall allowed values of this discrete random value. Summation xi times e. So what is it saying? What value can it take, and with what probability it takes that value? Yeah? You sum those up and you get the mean. ये क्या था ना यहाँ पे? When you did the center of mass, this is what you do. Yeah. So if it is continuous, if the random variable happens to be continuous, how would we define it? Any guess? Integral. I have already told you the principle. Yeah, summations replaced by integral. So it's minus infinity to infinity x f x dx. Yeah. So for continuous case, you take infinitesimal points. Yes, take their center of mass, and you get this definition. Now, again, essentially, the mean represents where the odds even out. So let's make the game more interesting. Let's say if we play the same game. If the head shows, I give you 1,000 rupees, and if a tail shows, you give me 100 rupees. Yes. Should you play this game? If a head shows, I give you 1,000 rupees, and if a tail shows, you give me 100 rupees. Should you play this game? Yes. Yes? So, what do you expect to win per play? How much? 900. Is it really? Let's see. So, this is all. Again, back to our experiment. Head, tails. Head, you get 1,000 rupees. Tails, you have to pay 100 rupees. Let's call this x1, this x2. Fair coin. Yes. So fx1 equals fx2 equals 1 by 2. What's different from the previous game? Probabilities are the same. And head or tail की तो वही है. What changed? The magnitude. दोनों की chance still same है. But that's not enough to find the expected worth of a random variable. You have to find also, okay, एक हो सकता है एक random variable की आप $1 million win कर सकते हैं. Yeah, but the chances of that happening are 10 to minus 19. क्या फायदा उसमें? Yeah, value is huge, $1 million. But when you multiply it with the chances of that happening, goes down, meaningless is that. Yes, so that's what lotteries work on. Idea of criteria. So fx1 equal to half. Okay. Now, what's the expected value? What's the expected worth of this game? How much do you expect to win per play? जी, किसी ने कहा 900? 900
per play 1,000.
You expect to win 1,000 per play? Expected value. Let's say we play this 10 times, for example. So you remember, you're dealing with probability. All 10 could show heads. Yeah, I know that would be a very strange occurrence. Can happen, but we're dealing with probabilities. So if you play this 10 times, how many heads? 5. How many tails? 5. So how many times you get? You get 5,000 rupees. Yes, 5 heads. how much you give me back? 500. 5000 minus 500 divided by how many times did we play? 10 times. So that should give you the how much you expect to win per play. अब कितना निकला? 450. Okay. So the mean is not a very simple thing. You just have to absorb it in your mind. That is the expected worth of some random variable or some random occurrence. In terms of center of mass, क्या होगा? How does it change? So, what are the possible values of x now? 1000 and minus 100. So 1000 is somewhere over here, minus 100 is somewhere here. Now where should you put the value? Okay. What's the probability of each, by the way? Still the same. Changing? Yes, probability is still the same. So should you still put the wedge here at 0 to balance out? Now I'm telling you the center of mass interpretation. Yeah. Here when we talk about 450 rupees per play, that was the expected worth. Yeah. So where should we put the wedge now? थोड़ा सा right पे. Yeah, 450, or if you don't know yet, okay, you at least you guess that it should be a bit to the right. So let's put it somewhere here, and let's call this mu of x, which is another name or symbol we use for e of x. Not equal to mu of x, we actually, let's say, represent it by mu of x also. Mean का जो common representation है, in terms of operator, it's called the expectation operator. Expectation operator works on this random variable. We also use a short symbol for it called mu. Very common. Yeah. X represents, that is the mean of a variable x. Yeah. Okay. So now let's see the center of mass interpretation. Yeah. So based on the center of mass interpretation, what's the moment arm? Let's say here. इसका moment arm क्या है? In terms of x and so let's say we said this is x1 and this is x2. Yeah. So what's the moment arm? x2 minus mu x. Yes. Here. What's the moment arm here? x1 minus mu x. So that will turn out to be a negative number. So you have x1 minus mu x. So this is the moment arm here. This is the length. This is the moment arm here. Now if we go by the moment arm interpretation, basically we want if mu x has to be the center of mass. अभी हम कह रहे हैं, ये भी कह रहे हैं है. I don't know where it is. Yes, I just put it somewhere. Yeah, then it's just a variable so far. So if mu x is to be the center of mass of this, what should happen? The moments, counterclockwise moments, should balance with the clockwise moments. दोनों को balance होना चाहिए. From your basic physics, you know that the balancing would require x1 minus mu x, the moment arm, times the force being applied, which is the force of probability. What's the likelihood of this happening? Is fx1 plus the other force, moment arm of the other force, that is x2 minus mu x times fx2. Now if mu x is indeed the center of mass, this sum should be 0. One of them is negative, the other is positive. Together their magnitude should be equal. अगर ये minus 10 बनता है तो this should be 10. If mu x is to be the center of mass. Yeah. From here, can anyone calculate mu x quickly? Tell me what's the value. Here is a triangle paper. There is an unknown here. Yeah. I'm assuming if mu x is the center of mass, it should satisfy this condition. Shouldn't it? So That should tell us how to find mu x in this case. Solve the dependency. Try it. You have an equation? Yes. The only unknown I am saying is what? Mu x. बाकी सब मालूम है. Yeah. So find it. इसकी expression निकालने पहले. Yeah. Then we will calculate the value. Expression mu x. So you know when you find expression, I mean that mu x should be on left and everything else should be on right. That's all I'm saying. Yeah. So क्या निकला? I will also start solving it to save some time. So x1 fx1. Write it from here, so it's faster. X2 x minus x fx1 plus fx2 equals 0. The expression आ रहा है नहीं? You get this at least? Yeah, it's just expanding this out. x1 fx1, yes, plus x2 fx2. There are two terms with minus mu x. I have collected them here. Now, there is something special about this. क्या है special? From the axioms of probability, the probability making sense. पढ़ा था ना? It has to be 1. Yeah, because we are saying this distribution only has two possible values, and whatever the values are, they have to sum to 1. So it possible values. So actually, this is 1. Now, if this part is 1, what happens? It simplifies. What is mu x then? With that as an example. Bring it to the right or the left, however you want it. क्या बना? Mu x is x1 fx1 plus x2 fx2, right? But notice, isn't this the definition we gave for the expected value? What was it? Expected value of a discrete random variable x is summation xi fxi for all xi. For our example of heads and tails of this 1,000 rupees, and there were only two xi's, yes, x1 and x2. So it had only two terms. This is it. So even from the center of mass, this definition does not come magically. See, it's actually calculated like this. You can now make the general case and actually get this distribution. You can make a continuous case and get the integral definition also. It's not a big deal. So now let's check our value. क्या कहा था हमने? 450 rupees. Yes, per plane. Yeah. So let's put that here now. X1 is what was it? Minus 100 times half plus 1,000 times half. It's very easy to see कि ये तो 450 ही बनेगा. Yes? You can just calculate it. It is 450. So back to the summary. What is the center of mass then? What is the mean value? The expected value is the center of mass of the random of the PDF or the expected one. Often we like to say that the mean is a location parameter. It tells us, okay, where is the distribution actually located. Okay. So for example, for heights, the mean might be 178 centimeters. So we get a feel for, okay, heights of people. So we may get, okay, heights of people are located somewhere in this range. Yeah. What about lengths of, say, trucks? Okay, do you expect the mean to be here or somewhere else?
Somewhere.
Udhar hi hai, further there. So the lengths of trucks, yeah, somewhere here. I'm not saying exactly how they are distributed, but we expect the whole distribution to move, don't we? इसलिए इसको हम location parameter भी कहते हैं. It kind of helps you locate, okay, start किधर करना है, where is the distribution gonna, should I be looking for the distribution here, here, further there, or in the negative range, depends what you are talking about, yeah? So the mean is also called the location parameter, okay? Alright. Now, quick question, what's the mean of a constant? So we know the mean of a random variable. Yes, we have the definition, we have the interpretation. What should be the mean of a constant? Constant means C, let's say there is a C, constant C. It's going to take some fixed value, not random. So let's say C will take 10 value. If you take C equal 10, C equals 5. Let's start with something easy. Let's say E, what's the expected value of 10? Random to नहीं रहा, right? So what's the expected value? क्या हो गया? 10 by क्यों? By 2. अगर जितनी इंटरप्रिटेशन चाहिए ना सारी आप कोई भी इनमें से अप्लाई करें तो you will get the answer. Either try the center of mass or try the expected worth. Okay, I tell you that C has a value 10. C is a constant. It has a value 10. हो गया? Random नहीं रहा, fix हो गया. Now what is the expected value of C? 10 होगी, right? 10 होगी ना? Now let's check our definitions. Our definitions say that the expected value of a random variable, if it is discrete, is summation xi fxi, isn't it? Yes? If I say C is equal to 10, how many possible values? 1. Yes? What's that possible value? 10. What's the probability of that possible value? 1. Because it's not random, it's deterministic, it's certain. Its probability is 1. So, there you have it. The expected value of C, a constant, which is not random, if it is 10 or whatever, so you can say, okay, expected value of C is C. Now let's try the center of mass interpretation. What does the center of mass interpretation say? How does this mean look like now? X can only take value C. Yes? No other value. Yeah? It can only take value C. What's the probability that it takes C? It's 1. Where should you put the wedge so that this thing doesn't fall? If you put the wedge here, it will fall to the right. If you put the wedge here, it will fall to the left. Where should you put the wedge? At C. Yes? But we already said that if you put the wedge and things don't become unstable, that is the center of mass, that is the mean. So the mean mu x has to be C, whatever C takes the right. So it is not magical. Sometimes we just tell the students the mean of a constant is the constant. Yeah, but it's not. It doesn't just show up from somewhere. Right? It makes perfect sense if you understand the interpretations. Okay. So what were the key information we were interested in? Mean, yes, the expected value. What else? Variance, covariance. Yes. So let's come to the second one. Variance क्या होती है? Any idea? What's the variance? सुना हुआ है बस. Standard deviation तो सुना हुआ. Yeah. So what's the variance of a random variable? Notice this thing. Two random variables may have the same mean, but one of them may look like this and another one may look like this right now. What's the difference now? The two have the same mean, symmetric and mean भी middle में आ जाता है. When distribution is symmetric, the center of mass interpretation directly tells you that the mean will be in the middle. Yeah, क्योंकि वो balance वहीं आएगा ना. If it's not symmetric, then the mean has to move depending on किधर weight ज़्यादा चला. Yeah. Okay. So what's the difference between these two distributions? Yeah. I could even make it like it's variance. Yeah. The values, the degree of spread here. This distribution, the upper one is more spread out. Yeah. This one is more concentrated towards the center. इसको हम कहते हैं variability. Yeah. Variation. Yeah. So, what's the mean of 100 and a minus 100? 0. What's the mean of a million and a minus million? 0. Variation किसमें जाता है? First case में second case. Second case goes from a million to a minus million. Yeah, huge variation. Mean फिर भी 0 है. What does it say? It says that mean alone is often not enough to make decisions. अब इस mean 0 है कोई परेशानी की बात ही नहीं है. Yeah, अचानक million value आ गई सब कुछ खराब हो गया. Yeah, so there is another parameter that really makes sense to have, and that is the degree of spread. So what was the mean? Location parameter, center of mass, expected worth. That was mean. Different interpretations. Variance, how much spread out. The पहली वाली interpretation है, that does not talk about how much spread out the data is. Down here, million minus million, mean is 0. So 100 minus 100, mean is 0. Yeah. Now let's say I want to play a game with you. I say that if there is a heads, you get 100 rupees. If there is a tails, you give me 100 rupees. Yeah. If the worth is, or even let's make it interesting. If there is a head, you get 1000 rupees. Yes. If there is a tail, actually I should make it different. If there is a head, you give me 1000 rupees. If there is a tails, you get 100 rupees. Okay. समझ आ गई? Heads, you give me 1000 rupees. Tails. If you should play it or not, maybe for fun you can play it. It's fine. You expect to lose, but you can play. But what if there is a heads and you have to give me 1,000,000 rupees, and if there is a tails, I have to give you 1,000,000 rupees. Now you expect to neither lose nor win. Yes. पर अगर ऐसा हो गया कि पांचों दफा हेड्स आ गया, आप पास है 5 मिलियन मुझे देने के लिए, 500 तो होंगे शायद आप पास, 5000 नहीं होंगे, राइट? 5 मिलियन तो नहीं है ना. So variation also plays an important role in the decision making. 5 million है आप पास नहीं है, so don't play that game. Even if you expect that the total leverage जो है 0 हो जाएगा, if you expect, because why? This is probability. Probability में 6 heads भी आ सकते हैं, कोई रोकता नहीं है उसको, हो जाएगा, right? So remember this, that the variation, the degree of spread, also has important information in it. So let's erase this and see the degree of spread. How do we mathematically write it? So we have operator for it. We call it the V, like E operator, acting on the random variable X gave you the mean. Now the V operator, variance, acting on the random variable X will give you the degree of spread. And this is how we define it. We say that I want to see my random variable X, how much it deviates from its mean. Okay. So the random variable X, whatever values it takes, yes, minus mean. So how much this is X, this is mean of X. So if X takes values here, it's deviating from the mean by this much, by this much, by this much, by this much, and on the right side it's deviating by this much. Now in this case, the deviation is either to the left or the right is not important to me. Okay, so because it's still a spread, we are interested in the spread, remember, yeah? So how much it deviates from the mean, that's what I'm interested in. I'm not interested in is it to the left or the right. We could be interested in that, and that's where skewness comes in, but in this course we don't do that. Yeah, mostly we are interested in how much spread. So to one way to take away the effect of positive and negative is to square it. फिर प्लस वाले डिस्टेंस और माइनस वाले डिस्टेंस दोनों स्क्वायर हो गए, पॉजिटिव हो जाएंगे. या यू कुड आल्सो डू एब्सोल्यूट, विच वुड मेक मोर सेंस. मसला क्या एब्सोल्यूट का? आपने कैलकुलस 1 2 किया, 1 किया. अगर आपको वंस दे गिव यू डिफरेंशियल ऑफ एब्सोल्यूट एक्स, सबकी जान निकल जाती है. यस, व्हाट्स द प्रॉब्लम? एब्सोल्यूट इज नॉट अ वेरी नाइस फंक्शन मैथमेटिकली. डिसकंटिन्यूटी है ना उसमें. Yes, so we usually avoid it because analytically it becomes a headache. Okay, so there is an easier way to say, okay, let's just square it, because we just want a measure of it. We're not really going for some exact thing. So so how much x is deviating from its mean value? That should give us some value spread. But is there something missing? Let's say it deviates to minus million and it deviates to plus 100. Okay, is it a high deviation? What is missing is what's the likelihood of that deviation. Okay, maybe it deviates to a minus million, but the chances of that happening are extremely low. Yeah, and it can deviate to a plus 100 and the chances of that happening are very high. Yes, then again the variability is not just how far you go, it's also how often you go that far. Yes, that will represent the overall variation in your data. Okay, that's why we need NT here. अब वो पिछली डेफिनेशन इधर आ गई है. Yes, it's the expected value of what? In the square sense, how much you deviate. So it's saying, basically it's saying how much you deviate, square that, multiply it by what. So you know, if you have E of x as summation xi f xi, then it's not too hard to see what this would represent. Okay, this would represent x minus mu small x minus mu x xi minus mu x square times xi summation overall xi. From there, yeah, it's easy to see. We will not prove it exactly, but the expected value of this whole thing is basically what values it takes. No, right, it has to be fxi, sorry. So it's how much each value deviates from the mean per square sense times what's the probability of that deviation. That if you multiply that out, that is the expectation operator, and this now gives you the degree of spread of a random variable. So this I have written for discrete case. Continuous में क्या होगा? Yeah. So for continuous case, it will be an integral x minus mu x square fx dx minus infinity to infinity. Discrete में हम कहते हैं over all values of xi. In continuous we say minus infinity and पूरी range continuous numbers. Yeah, or wherever this will be fine. So this variable will be able to capture this is, what do we call it? Variance. Yeah, variance. What does it capture? The degree of spread. If you calculate these two, let's say you have these two distributions, one looks like this and the other one looks a bit like this. Okay. Remember, even if their minimum and maximum values are the same, yeah, which one has more variance? Which one has more variability? This one. Yeah. Why is that? So this one has more variability because they both have the same mean. They are symmetric, so they have the same mean. But notice, although this guy, the thin one, deviates from its mean, but the chance of that huge deviation is very low. Here, it has huge deviations with a high probability. Yes. So the variance has to cover both things. That's why the expectation operator comes in. So to summarize, what does variance represent in terms of concept? Firstly, you could simply say it's the degree of spread, how much the distribution is spread out. So mean told you where it is, location, yes, and the variance told you how much variation to expect, yes, expectation. Yeah. Now, from the mathematical understanding, it's also useful to remember that the variance is saying what? On average, how much does the random variable deviate from its mean? Will be spread over. Yes, that's all. Yeah. So, of course, random things can have different kinds of variances. So, for example, let's say I've already mentioned the high variance. So this is high variance, this is low variance. What about, let's say, the distribution looks something like this? Is it high variance or low variance? So overall, compared to say this one, it seems like it is high variance. Why? Because it deviates with very high probabilities. Yes. So it is again high variance, but of course you have to decide what it means. Now again, question for you: what's the variance of a constant? सोच के plan कीजिए. अगर आपने interpretation समझ आ गई है, then you will answer immediately. But of course, it takes time to resolve. Constant आ गया again C. Yes, C means here constant means deterministic thing. It's not based on a random event. Let's say C can be 10, 5, कोई एक fixed value. So what's the variance of C? Zero. Any other answers?
जो कितना दूर है उससे मीन से
उसका मीन क्या है? क्या होगा? Constant है ना, तो उसका let's say constant is C. What's the mean of C? C. How much does it deviate from its own value? करते नहीं है, वही रहता है. So you can apply the definition, or you can just see. So what did we say the definition was? It was expected value of x minus mu x square, was it? Yes. Now we said, okay, in discrete case that would be xi minus mu x times fxi over all xi. Now if x is c, a constant, not really random here, then what are the possible values of xi? Only one. What is that value? C. So you will put C here. No need for summation because it's just one value. Minus, square here, minus the mean of this value. The mean of the constant is constant itself. So C minus C times, it doesn't really matter what time it is, but this will be the probability of C happening is already 1, but doesn't matter because this will already make it 0. Yeah. So the variance of a constant is 0 based on the formula, but also it's very easy to see. What was variance? We are saying on average, how much does the random variable deviate from its mean? Now, if it's a constant C, the mean is here, mu x is C, and it happens with probability 1. So C, how much C deviates from C? Doesn't deviate at all. So the variance, now this is an important result, variance of a constant is 0. Constant has no variability. वही रहता है. Yes. So again, nothing magical here. It's a result that can be shown very easily. Let's see. Now, what did we cover so far? Key information, mean and variance. Yes. Now within these, we saw them as operators. Some important properties of the operators. Firstly, they will help you in analysis. Concept अगर आप clear कर लेंगे ना, that is the key thing. Yeah. But now what follows now is rigor. Rigor पता है क्या? Mathematics rigorous, being able to solve equations very efficiently. Yeah. To really go into the nitty-gritties of the mathematics. Yeah. But that's also needed. But ये जो अभी पहले मैंने बताया ना, this is the key that should be in your mind. Because this will help you answer a lot of other questions that rigor may not be able to answer directly. So, expectation operator is linear. Okay, some properties of the operator, linearity. Firstly, this thing. Okay, what do we mean by that? If there is a random variable x, ax is a constant a, let's say, and there is a random variable y multiplied by some constant b, yeah, then it is simply a matter of rewriting it as plus. This is always true, no matter what distributions x and y have. So we say the expectation operator is linear. In addition, you can also bring the a outside. Why is that? You will see, of course, you know, but there is some further proof here. I will skip that. The constant doesn't really affect the mean. Okay, so EAX, it affects the mean, but what I mean is that it can be separated out here. So we say the expectation operator is linear. Now this can be expanded. Okay, so you can write it as summation AIXI is the expectation of the sum. Right. Now another important result is the function. So expected value of x kya thi? Let's say for the discrete case, we had it xi f xi. Yes. So expected value of a function of x. Yeah. Can anybody tell me? Function could be any function. Yeah. Like for example, expected value of x is here. Let's say I say g of x equals x squared. This is one function, quick function, log of x, sine of x. Yeah. So now, expected value of x has this definition. Interpretation आपने देख ली. Yeah. What would you expect the expected value of a function of the random variable to be? क्या होगा आपके यहाँ से?
So g of x of y.
Exactly. Because notice, this was representing the moment arm, right? The length. When you do the center of mass interpretation, it was the moment arm, xi. Yeah? By applying an operator to it, you change the moment arm. Change कर दिया ना उसको, x square कर दिया. जहाँ 4 था moment arm वहाँ 16 हो गया, depending on what function you apply. So the moment arm is now gxi. But does the probability of this change? No, because it's still the same. Yeah. So xi takes the value xi with probability fxi. What is it? Yeah. So this is the continuous discrete case, and for the continuous case, just replace this by the integral. So we say that it is easy to find if you know the mean of a random variable, at least the formula here. You can also find the mean of a function of random variable. Okay, you know the function, just replace in your definition xi by gxi. The rest remains the same. Okay. Another thing is non-multiplicity. They are linear, okay, but non-multiplicable. That means exy is not equal to ex ey. You can try to write it from the basic definition and see it. In general, this is the difference. So ex plus y, yes, it is linear, so it can be ex plus ey. If there is an addition operator here, you can simply separate them. Always. You don't have to ask the properties of x and y. In case of a product, no. But there is a special case when that is possible, which is if x and y are independent. Yeah, the independence हमने पढ़ा. Probability x given y equals probability of x. The information makes no change. Yeah. If they are independent, then this is separable. Exy equals ex ey. So if x and y are independent random variables, then the product can be separated into, again I said this is rigor now. Yeah? We are adding some things that will help you actually solve problem. So I will not start the next topic. I will just set the foundation for that in the next 2 minutes, and then we will cover that. क्या रह गया है वो? आपकी चीज क्या रहेगी? पता है मुझे क्या? Right. So please also see some of the, similarly in your book you can see some properties of the variance. आपको याद है variance क्या था? Variance of x, we defined it as x minus mu x square, right? And it also has a symbol. आपको पता ही है, mu sigma x square. The square emphasizes this square. Okay? इसका square root ले लें तो ये क्या होता है? Standard deviation. Okay, so there is no magical. Variance is the real concept. Its square root is standard deviation. So in this case, we can write things. We can write ex. इसको आप expand कर सकते हैं square को, right? A plus a minus b square कर सकते हैं. आता है आपको a square plus b square minus 2ab. If you do all of that, I won't do it here. You actually come to another formulation of the variance, which looks like this, and this is actually saying it's ex square minus mu x square. It's a useful result, so just see it in the book again. What is it saying? It's saying that you can actually expand this thing into two terms, and it often comes in handy when we're doing rigorous math. Solve कर रहे हैं बड़ी-बड़ी equations. It comes in handy, but this is going conceptually there's nothing new here. Just expand it, you solve it, you will see it comes in. What I really want to show you before we close this lecture and connect to the next one is this thing. Let's say there is a random variable z, which is ax plus by, okay, and if you are given that so you know the mean and variance of these guys. So their mean, the mean of x is mu x, the mean of y is mu y, the variance of x is sigma x square, the variance of y is sigma y square, and you are asked to find what is the variance of z, this guy. Okay, so if you want to try it, you will see, okay, by definition it has to be z minus mean of z squared, right? Has to be that thing. Now let's start here. What's the mean of z? Can somebody quickly tell me? mean of z. Apply the expectation, yeah? E of z equals a e of x. The other expectation is a linear operator, isn't it? So e of z is a e of x plus e of y. What is the name we give it? Mu x plus b mu y. And this we will call mu z. So now you have mu z in terms of x and y's mean. Both are. Now, what about, can I replace z by ax plus by? Yes, I can. So this is what I will do. We can say, okay, it's ax plus by minus a mu x minus b mu y whole square. I have just expanded this. Z की जगह मैंने ये रख दिया. Yes, and place of mu z I have placed whatever you found. Now, if you work with these equations, expand them into squares and everything, you will come up with this thing. A square sigma, I'm not going to do it now, but you can see b square sigma y square plus 2ab expected value of x minus mu x times y minus mu y. Basically, you are finding what? The variance of z. What will it come out to be? It will be a square times the variance of x plus b square times the variance of y, which is fine from here. All of these, if you solve the squares, plus 2ab times this thing. What is this? This is interesting. This term covers only variable x. This term covers only random variable y. Yes? But this term is interesting. It has both of them. Yes? It is the expected value of how much x deviates from its mean times how much y deviates from its mean, mu y. And this has a special name called covariance. The degree of joint variation. We will see that next time. Okay? We will define it and cover its mathematical details. Okay? So, as usual, you can ask me questions if you have now or approach me later. It's fine. Yeah.